So in today's video, I'm going to explain solution of recently asked Codeforces round 891 rated for division 3 solution for problem E. So the name of the problem is E power of the points. So first let us understand the problem statement. So the what problem is said that we will be given an integer array A, and what we can do, we can select any number from that array itself, and we can define the ranges from that number to every other element in that array which are present in the array. And now what we have to do, we have to choose all the numbers from 1 till 1 to raised power 9, and we have to tell them that what is the occurrence of 1, what is how many times the 1 occur in that segments which we have created from the array itself by choosing a single number and taking the pair of all the number from that number. And we have to tell them what is the sum of all the occurrences from 1 to till 1e9. For example, in this case, I have an array like 1, 2, 5, 7, 1. Now if I choose the element as 5, so now what can I do? I can define the ranges as 1 to 5, 2, 1 to 5, 1 to 5, then 2 to 5, then 5 to 5, then 7 to 5, and at last 1 to 5 again. Now what we have to do, we have to tell them what are the occurrence of 1 plus occurrence of 2 plus occurrence of 3 till occurrence of 10 to the power 9, and what is the sum of all the occurrences in that array. And by occurrence I mean how many times a number I occur in that segments which we have created before. So I hope the problem statement is pretty much clear to you. For example, I can show you this example. For example, in this case, they have chosen a integer number, integer 5, and created a ranges like this. I have told you previously. And what they have chosen the what are the occurrence of 1. So the occurrence of, we can see that the number of time 1 occur in that segments. So we can see my number 1 occurs in two segments which are 1 to 5 and 1 to 5. So occurrence of my 1 is 2. Now I have to check what are the occurrence of number 2. So the number of occurrence of 2 are indeed 3, because my number 2 occur in this subsequence, because 1 2 3 4 5 2 comes in this array subsequence or subarray, whatever you can say, and 2 also come in this array because this starts with 2, and again at last my 1 to 5 is also present again 2 times. So I can say the number of occurrences 3. Similarly, number of occurrence of 3 is 3, number of occurrence of 4 is 3, and number of occurrence of 5, 6 and 7 are respectively given to her. Now you can see the number of occurrence of 8 is 0. Now we can here see that the maximum element present in the array will be at most that number till which we have a integer number greater than 0 number of occurrences, because here we can see my largest number is 7 in the array. So the all the occurrences of the number which are greater than 7 will be always 0, because there is no point counting in them. So the sum of all the occurrences till 1 to 7 is 18. So the answer for this 5 is 18. So now what problem is said, we have to choose every number from 1 to n, and we have to calculate all the segments from that number to all the other elements, and we have to tell them for every element what will the sum of the occurrences from 1 till 1e9. For example, in this case you can see, if I choose a segment, if I choose my S as 1, now then my segments will become 1 to 4, 1 to 3, 1 to 2, 1 to 5, 1 to 7 and 1 to 1. Now what will be the occurrence till 1 to 7 in that number of segments, that is equal to 16. So I hope problem statement is pretty much clear to you. So now let us begin to the problem solution. So here I have written something from that you can understand it better. So here you can see, if I choose my number as 5, here in this case I have choose my number as 5. So all the segments which will be look like this, because 1 to 5 is coming 2 times, then 2 to 5, and then 5 to 5, and then 7 to 5. These are all the segments which will be created. Now if I find what will be the occurrence till 1 to 7 in these segments. So in these segments you can see my number 1 came 2 times, number 1 came 2 times, number 2 came 3 times, number 3 came 3 times, and number 4 came 3 times, and number 5 came 5 times. Because my number, this is a valid reason, because why my number 5 came 5 times, because it is present in all the arrays, and because it is present in all the segments, and my number of segments will be 5. So I can clearly say the number which I am choosing, the number of time it will occur will be always equal to n, which is my size of the array. So number of time my 6 come is 1, and number of my 7 comes is also 1. So here by see you have to see a pattern in this. And what will be the pattern in this? Because see, you can see what will be the answer for 5. The answer of 5 will be indeed the sum of all these number, and the sum of all these number will come 18. So here you can see the sum of all these number will always come equal to 18, because you can see 2 plus the sum of all these numbers is 18. So here you have to see a pattern. And what is a pattern? The pattern is that if I sort my initial array A, because if I sort my initial array, which will be then look like this. This is the sorted array A. If I sort my array A, it will be look like this. So what I can do next, I can simply take the adjacent difference of the sorted array. So what will be the adjacent difference of the sorted array? Here 1 minus 1 is 0, 2 minus 1 is 1, 2 minus 5 is 3, and 5 minus 7 is 2. So this is the difference of my sorted array A. Now what can I do? If I choose a number 5, for example, in this case I have chosen number 5. So in this difference array, where does my number 5 occur? So in this difference array, my number 5 will always be occur in the difference between its left adjacent and its right adjacent. So difference of its right adjacent is 2, difference of its right adjacent 2, and difference of its left adjacent is 3. So which I can clearly say my 5 occur here in this here in this difference array. So from this I can see if I if I start my numbering from first index till my number till my number 5 came. Because here you can see if I start a numbering from 1 2 3, because if I start a numbering from 1 2 3, you can see because first of all you have to calculate where does my 5 occur in the different array. So in my difference array, my number 5 came in this position. So now what I have to do, I have to take a variable k, and mark it as 1 here, and then I have to increase till my position of my s came in. So my s or my number 5 came here. So I'll be increasing my number in this form. So here I will get 1 2 3. Now when my 5 occur, I have to stop. Similarly I have do it from the right. Here I can see I have only one element left, so I will simply write it 1. So here you can see here is a pattern. So you can see in my answer array how many times my 1 occur. My 1 almost. So here you can see here is a pattern how many times my 2 occur. Here, so let's start from 1, let's start from 2. How many times my 2 occur? My 2 occur almost 1 times, because my 2 is only here. So here with respect to 2, my corresponding difference is 1. Now how many times 3 occur? 3 occurs 3 times. So how many occur 3 times? The 3 is like this, 1 2 3. So here you can see my 3 also occur 3 times from this array. Now how many times 1 occur? Now how many times my 1 occur? My 1 occur at most 2 times. So here you can see my 1 occur at most 2 times. So this is the only pattern. What we have to do, we have to first sort the array A, then we have to take the adjacent differences of the array A. Now what we can do, we can simply choose the position where does my position of that element came from, which we are segmenting the array, and we have to mark that position. And from that position I have to multiply all the differences with respect to increasing number. For example, in this case I have my difference array is like 0 1 3 and 2. Now my sequence will be like 0 into 1 plus 1 into 2 plus 3 into 3, and from here from right side I will do 2 into 1. So if I show you another example, here is another example. In this example I have, you can see in this example you can see if I took my if I took my if I choose my index 7. So what will be the segments? So segments will be 1 to 7, 1 to 7 2 times, then 2 to 7, then 5 to 7, then 7 to 7. So here you can see my these segments, my 1 occurred 2 times, my 2 occurred 3 times, my 3 occurred 3 times, 4 occur 3 times, 5 occur 4 times, 6 occur 4 times, and 7 occur 5 times. Because 7 is the element which we are using, so it will be always equal to n. So now what can I see? I have segmented my array like this. So in this way, this is a sorted array. Then I will take the adjacent differences. Now I will check where does my 7 occur in this difference array. So in this difference array, my position of 7 will be at this position. So at this position. So starting from this position to the right, I will mark a variable as k is equal to 1. Then I will multiply it in the increasing number from my adjacent difference. For example, in this case, my adjacent difference is like 0, 1, 3, and 2. Then I will multiply 0 with 1, 1 with 2, 3 with 3, 4 with 2. So now what is the pattern here? So you can see my 2 occur 1 times. So here you can see my 2 occur 1 times. So here you can say my 2 is occurring 1 time. My 3 occur 3 times. So 1, 2, 3. My 4 occur 2 times. 4 and 4. And indeed the 7, which is always equal to 5, which we have to plus. So the answer for 7 here it is 24. So if you will sum of all these numbers, which will be always equal to 24, or you will take the sum of this number in which these are or multiplying, and you have to sum all these numbers which will be also equal to 24, and don't forget to sum. uh, so basically this will be equal to 19. So what we have to do, we have to sum the number of occurrences of 7, which will be equal to the size of array, because it is coming in the atmost by number of element present in the array segments. So it is always equal to 24. So here you can see how can you find answer for the single integer. Now what problem has asked, we have to find the answer for all the numbers. So a clever way you can do this is a greedy approach. For example, here I have written this. So what problem is asked in, so if I break the array, if I break the problem into sub problem, so here you can see. So if my adjacent differences were like 1, 2, 0, 1, 2, here it is 3, and here it will be 2. Yes. So what problem has asked us, asked us to do? For example, if I choose my first integer in the sorted array, we later uh, will we manage the sequence later. First, let us understand what will be the case of sorted array. So in sorted array, if I choose my first number, which will be equal to, so if I erase this, wait a minute. So in this case, if I choose, if my array, if my array was like this, for example, in this case, the sorted array was 1, 1, 2, 5, 7. So here in this case, so if I want you to calculate the answer from 1, so answer for 1 will be equal to, I will partition my array like this, and but I will say you that you have to calculate the difference from difference here, from the difference into corresponding number multiplied by increasing number. For example, if I take this, then I will multiply this number by 1, this number by 2, this number by 3, and from this I will multiply this number by 1. So sum of all these number plus my plus my size will be my answer from 1. For example, if I give you another example, if I show you like this, so here you can see, here all the numbers which I will be written. For example, if my corresponding number is at this position, so at this position I will choose my difference array, and I will multiply it by this number. So my difference array was 0, 1, 3, 2. So my if my number lies at this position, so let me choose another color. So if my number lies at this position, so my answer will be, so if my number lies at this position, so my answer would be answer would be this, and this adjacent difference multiplied by this sequence, this number sequence. So if my answer lies at this position, So my what will be the answer? My answer will be adjacent difference into multiplied by this number and this number. So if my number lies at this position, so my answer will be this multiplied by this. So if this position, then this multiplied and this. If at this position, then at this number. So I hope the problem intuition is clear to you. So, and one more thing you can ask. So what is the proof? This answer is always correct. This answer is always correct. So if you ask me what is the intuition behind this problem, so how I have figured this pattern out. So if you want to figure out the pattern, you can try to run different test cases on your pen and paper. Then you will initially found how I have reached this pattern. So if you cannot reach this pattern, you can comment in the comment section. You can comment down. I will tell you how I am coming up to this pattern. So if I show you the code, the the implementation is pretty much tricky one. So because you have to do this question is log of n space. So what I have done, I have taken my input array n, input array a, then you can leave this part from the from you can leave this part at this moment. So what I have done, I have initially marked my array b and sort that array b. Now what I have done, I have taken the difference between the sorted array. Now what I have done, I am taking the right sum. Now if you ask me what is the right sum, so right sum, for example, in this case my right sum will be 2 into 1 plus 3. For example, in this case, for example, the case like this, in which my array is my number is at position this. So my what will the answer for this? This answer for this will be always adjacent difference into multiplied by 1 2 3 4 corresponding numbers. So in this case I am counting the right sum. So my right sum would be difference array multiplied by number k. Then I am always increasing my number k. So here in this case I'm calculating the right sum. By calculating the right sum, I got my answer for this number. So now what I have to, I will also take my left sum. So I will initially push the right sum plus n, because n is the n plus n, because I am adding n, because this number doesn't count in this sum. So I will add initially. So I have to add extra n for this number. So now what can I do? I can simply calculate my left sum. So my left sum would be, for example, in this case my left sum is 1 multiplied by adjacent difference. So my 1 multiplied, so I have initialized k again with 1. So now what I will do, I will multiply my difference at I with my integer k and add it my left sum. And what I have also do, I will also remove my right sum at this position. So for example, in this case my right sum was 4. So I will delete this 4 into 0 and I will add 0 into 1. So my sum will become 0 into 1 plus my right sum was this initially. So I erased this one. So my right sum which is left is this one only. So my sum is this plus this, and this is the answer for the second number. So I will push that number in the array and I will add plus n for that, because that number count in all the segments. So now at the end, what I have done, I have calculated the right answer for the sorted array, but the initial array was not sorted. Then what I can do, I can simply check. I can simply check, because here you can see what is the answer storing. Answer is storing the right answer for the sorted array. The sorted array was my B array, because I've initialized the array B as A and sorted it. And but my answer is containing valid answer for sorted array A, or I can say my answer is containing valid answer for array B, which was sorted form of array A. So now what can I do? I can calculate the occurrence of B. I can calculate the occurrence of my occurrence of my every element of array B. Or but how I am calculating the occurrence? First I have stored the all the occurrences of array I in another set. So what I am doing next, I am just retrieving the number corresponding to that number which was in the array B. Then once I am getting that position, I will simply put my answer at I, because my answer at I is the answer of my B at I. Then I will put my answer in I will put my answer is that position, which was originally in array A. So once it is done, you will get your answer, and simply you can print the answer. So this is the whole problem intuition. So if you want the proof of this solution, how I am coming to this pattern, or how I have created this pattern, so you can comment me down, or you can try it yourself. How is this pattern possible? So it is just simple. You can calculate the difference between the adjacent, and you will get how that number is coming only that times, and how that sequence is working. So if you have any doubts, you can comment me in the section. You can comment me in the comment section. And till then, stay tuned for the next one. Thank you.